Okay, let's look at what kinetic energy means, right? Kinetic energy is the energy possessed by a body due to its motion. Right? So whenever a body is moving, when it has got some velocity, we say it has got kinetic energy. So every moving object has got kinetic energy. We will denote it by the symbol K. So capital K would mean kinetic energy. Let us say we have an object which is on the ground. Let us say this is a ball which is on the ground. It has got mass m. Let us say we apply a force F to this ball. Right? So we have an object of mass m, and of course it's at rest. So initial velocity of the object is 0. So we have an object at rest of mass m, and let us say we apply a force to this body. When a force is applied onto this body, the body will start moving along this path, right? And let us say that it reaches this particular position, right? This body of mass m, it has reached this particular position. At this position, its velocity becomes v, right? So that is its final velocity because of application of force. And the distance covered is, say for example, s, right? And the body may continue to move further, right, and may come at rest. But what we are saying is that we have applied a force F, and after the body covered a distance s, its velocity became v, right? So, what is the kinetic energy of the body at this particular point in time when its velocity is v? That is what we are trying to look at in this particular video. Now, the kinetic energy of the body at this particular point is because of the force applied over here. So this particular force has made this object move along this particular path. That means it has done work, right? And this work has got converted into kinetic energy. Remember in an earlier video we said work and energy are two sides of the same coin. When we do work, we give energy. So this particular force which has been applied, it has caused a displacement. So we have force and displacement, which is work done, and that work done has caused this body to gain kinetic energy. So if I want to find out the kinetic energy possessed by the body at this particular location, I need to find out work done. So I need to find out work done by the force F, right? And the work done by the force F is given by F into S. Right? General formula is Fs into cos theta. Since the direction of the force and displacement we are taking same, right? Theta would be 0. Let me write that. Would be Fs into cos theta, but since here the direction of force and direction of displacement is happening also in the same direction, so theta will turn out to be 0, and this formula will become F into S. So the kinetic energy of the body is equal to work done, and that is force into displacement. Force is mass into acceleration, right? And from second law of Newton's second law of motion means that force is mass into acceleration. That is, the force applied is equal to mass of the body into the acceleration that happened. And distance can be taken as v square minus u square upon 2a. From where did I get this? We know that v square minus u square is equal to 2as, right? So s will be v square minus u square upon 2a, right? And I have put this particular value over here for displacement, v square minus u square upon 2. So this will give me m into a will get cancelled, so I'll have m upon 2 into v square minus u square. So kinetic energy of the body is m into 2 into v square minus u square. Since the initial velocity is 0, we saw over here initial velocity is 0, u is 0, so this will become m by 2 into v square. And from this we get that famous equation of kinetic energy, half mv square, right? So half mv square. So kinetic energy of an object is half mv square. M is the mass of the object and v is the velocity. I want to stress over here, the velocity v over here is the instantaneous velocity. Quite a few times I make a mistake in the spelling of instantaneous. I think here I have got it right. Instantaneous, yeah. So v is the instantaneous velocity of the body, right? So When the velocity of the body changes, and say for example v becomes v1, then the kinetic energy at that point in time becomes half mv1 square. So what we are saying in other words is that kinetic energy K is an instantaneous property for body, meaning that as the body keeps on moving, right? If I draw an object over, path over here, and let us say there is an object which is moving in this direction, so it will be at different locations at different points in time, and at all the different locations the velocity will be different. Here it will be, say for example, velocity will be say v, here it will be v1, here it will be v2, here it will be v3. So the kinetic energy will keep on changing. The mass remains same, m. So kinetic energy here will be half mv square, here it will become half mv1 square, here half mv2 square, and so on and so forth. So the kinetic energy of the object will keep on changing as its velocity keeps on changing, and hence this v is to be understood as the instantaneous velocity of the body. I hope you got some idea about what kinetic energy is, and K is equal to half mv square. In the last minute or so, what we will do is we'll try to find out the unit of kinetic energy and just check whether it turns out to be the unit of energy or not. Half mv square. The unit of mass is kilogram, and the unit of velocity square will be meter per second into meter per second. Now we know that 1 Newton is kg meter per second square, right? So let me show it like this: kg meter per second square. This particular term, kg meter per second square, is Newton, right? So this will turn to be Newton, and then I have meter, and Newton meter is joule. So half mv square will give you a unit of joule, right? And thus kinetic energy of the object is half mv square. This was just to confirm that we're getting the unit of energy when we solve this particular value. Thank you.